Okay, hello, I'm back with question 3. Alright, Sita Mary walks 1.4 kilometers at decreasing speed to her school, only to remember she forgot something and walk 500 meters back at increasing speed. Okay, she then stopped as she recalled she left the item in school instead. Okay, journey to this point took 450 seconds. Okay, state what is meant by speed and velocity. Okay, please note that these two definitions are actually part of your learning outcomes. Okay, so please memorize them word for word. Okay, we do not accept alternatives. Alright, so speed is distance moved per unit time. Okay, velocity is the rate of change of displacement. Okay, you cannot tell me velocity is displacement over time. I will not accept. Okay, I'll give you 0. Alright, so the SI unit for speed and velocity is the same. Okay, meter per second. Right, state a work equation for calculating average velocity. Okay, so average velocity will take total displacement over change in time, or change in displacement over change in time. Alright, okay, we move on to calculate average velocity for this journey. Alright, so here we're going to need to know how to deal with vectors. Alright, so for vectors in general, whether it's displacement, velocity, or acceleration, we always have a conventional positive direction, and this conventional positive direction we normally take it to be where the object initially is moving. So if Mary is let's say moving to the right, alright, maybe the direction right is the way to school. So Mary initially moving to the right, then I take the positive convention to be to the right. That means to say that this 1400 meters is actually in the positive direction. Okay, you will see later on she actually moves back 500 meters, right? And because this 500 meters is opposite to its original direction, I must say that this 500 meters is actually a negative vector. Alright, because it's opposite to my convention positive, right? So this is the convention. Take right to be the positive is called the convention. Alright, you can set this convention, but generally you set it along the line where the object initially moves, or in this case where Mary initially moves. So if Mary moves to the right, I take right as positive, and therefore left is negative. Okay, there's no other direction. I cannot go up and down. Okay, in your context you do one dimensional motion, right? So if I initially start moving right, later on I can only move left. Okay, so how to find average velocity? Right, you will find the change in displacement over change in time, which in this case is actually taken from here to here. Right, so this displacement is always shortest distance from the reference position, which is normally the starting point, to the end point. Right, so displacement is this one. Okay, please note that displacement in this case is positive. Alright, because it's in the same direction as my convention. Right, this is my convention. Right is positive. Okay, this is my convention. This is called a convention. Alright, why did I choose this convention? Because initially she moved in the right direction, therefore I choose this as my convention. So that this is a positive 1400. But later when she moved like that, it's negative 500 because it's opposite to my convention again, right? But in the end of the day, if I want to find the displacement at this point, right, at this particular point where she is right now, right, is the shortest distance from the start or reference position to this point, right, which is in this direction, which is to the right, and therefore my displacement is actually positive, as you can see here. Right, so this calculation must come from the diagram. Okay, you must look at the diagram to calculate. Alright, and then you divide it by the time. Okay, so that's average velocity. Okay, sketch Mary's displacement time graph. Right, this one is always a little bit of a difficult thing for students, but don't worry, we'll try and go through it here. Right, so a displacement time graph will look something like that. Okay, this is displacement. Okay, I'm sorry about the handwriting. Alright, in meters, sorry. Alright, and this is time in seconds. Alright, so she takes some time to travel this 1400 meters, and they said is at decreasing speed. Right, we know that the gradient of a displacement time graph is actually the velocity. Right, so the velocity, right, is decreasing. Right, so remember from what we discussed last session, decreasing velocity means the gradient is getting less and less steep. Alright, so but before that we know that the initial displacement, which is this one, is in a positive direction. So I know I start from somewhere here and I end somewhere here. Alright, because this is positive displacement. Right, this is all the positive numbers are here. If I move in a negative direction, right, if I from here move this direction, right, let's say I move in this direction, then my right is positive, right, I will actually start here and end up here, because this is the negative displacement. Right, let's say this is negative 1400, right, this positive 1400, right, which corresponds to this line. Right, so I know straight away after some time I will start from this position and end up this position. The question is, does my graph look like that? A, B, or C, right? So there are only three options to go from here to here. You're either this type of curve, you're a straight line, or you're this type of curve, right? So let's check out which one gives me this criterion, which is decreasing speed, right? So you check out the first curve, right? Initially the gradient here is high. Can you see this gradient here? Okay, I'll try and draw this out. So this curve A, right? The gradient is high, then I become less steep, then less steep. You see, I'm getting easier and easier. So in this case, the gradient is decreasing, and the gradient is the speed, which means that this is correct, right? Let's check the others just in case. This is a whole straight line, so the gradient here is like that, gradient here is like that, gradient here is like that. That means the gradient is constant, right? The steepness is constant, therefore this is constant speed, right? So this is wrong because the question say I'm decreasing speed, right? So I already know this is correct but I'm going to test the last one, right? So I say okay, this one, see the gradient, easy to walk, hard to walk, harder to walk, right? So this one gradient is increasing, and therefore this is wrong as well. I'm looking for decreasing gradient, right? Then after that, when I hit 1400, I know I backtrack by 500. That means to say from here to here, I move negative 500. How to move negative 500? I must move backwards. So I start from here, I end up somewhere here, and this length here is actually your minus 500. Okay, because I already moved 1004 in this direction, right? So now I move back by 500. Now the next question is again, do I use this graph, or this graph, right? I'll leave you go. Okay, never mind, I'll guide you through. Let's look at the answer. Let's look at the question. Sorry, it's increasing speed. So I know my gradient gets higher and higher. So let's investigate these three options. All right. Okay, so investigate this one. Is it increasing speed? Right. You can see the gradient here is very high. It's hard to walk here because it's so steep. Right. Gradient here is less high and less high. Alright, so this one is actually decreasing speed because the gradient is dropping. This one, you know, is constant. It's the same as this one. It's just the other way around, but it's constant speed still. So this one is wrong, this one is wrong. And the last one is this, right? If you have this, you realize that this is actually easy, hard, hardest, right? This getting harder and harder to walk because it's steeper and steeper. So this is the case whereby you get steeper and steeper means gradient is increasing, which means speed is increasing, right? Which correspond to what is in the question, right? So this part is actually speed increasing. I know this is the correct answer and this is the correct answer. So this is the correct graph and this is the correct graph, and that's how you end up with this one. Can you see that? That's how I pick this one and this one, right? So when I know how to go from here to here. Then I choose between these three options, 1, 2, and 3. Okay, likewise with this one. I also have to pick from the three options which one to give me this one. Okay, can?